Hi there, so let's do this question. It says the upper part of an hourglass can be modeled by a cone with a radius of 9 centimeters. So here it's a cone, radius 9 centimeter, and the height of 30 centimeters. When it's full, it requires exactly 1 hour to empty, right? 1 hour to empty into the lower part, assuming that the sand falls through the opening at a constant rate. How fast is the level falling when 20 minutes have elapsed? Okay, so first let's see what information we have. We have the radius and height, so volume of cone is 1/3 of pi r square h. We have radius as 9 centimeters and we have height as 30 centimeters, right? So we can use that. It says that it requires exactly 1 hour to empty. So to empty the cone, it is 60 minutes, 1 hour, or 3600 seconds. We'll see what we have to use. And they haven't given us the constant rate, but they have given us the volume and they have given us the time. So we can find the rate. So rate is equals to volume over time, right? Volume is 1/3 pi r squared h over time is, let's take seconds, just because centimeter per second would look better than centimeter per minute, kind of. But you can use minutes if you want to use, that's fine. Let's solve that. So we have 0 cancelling 0, 3 cancel 3, 9 times 9. So one of the 9 will give us 9 fours are 36, 0. So 9 pi over 40 is our rate, right? And rate is dv over dt. So we got dv over dt here already. All right, next we have to now find, what else do we need? Right, so how fast is the level falling means we have to find dh over dt. How fast is the height falling? That should be equals to dh. We have the formula, so we can do dh over dv or dv over dh and flip it around, times, we need dt at the bottom, we have dv. Right, so now let's find, so dh over dt is equals to, now first let's differentiate this. So dv over dt is equals to 1/3 pi r square, because when we differentiate with respect to h is going to be 1. So dh over dv is equals to 3 over pi r square. We're going to use that. So 3 over pi r square times dv over dt. We have just found dv over dt as 9 pi over 40. Good. Now let's simplify that. That can cancel, pi times pi. Let's substitute the value of r, which will be 81, 9 square, 9 over 40, 9 times 9, 3 times 3. So we have 1 over 3, 4, 120 dh over dt. So this is centimeter per second, right? We have to find this thing, how fast is falling at 20 minutes, right? If you would have done minutes, it would have been easier then, I would say, but it's fine. 20 minutes is 20 times 60, it's 1200 seconds. So 1200 seconds, you have to multiply. So here it's going to be 1 over 120 times 1200, because this is per second, per 1 second. So if you multiply by 1200, that's going to give us 420 minutes. And when you cancel this, you have 10, right? And 10 is centimeters, because this is the height, right? Because that's what we are finding. we are finding, assuming that sand falls through this, how fast is the level falling when 20 minutes have elapsed. So when 20 minutes have passed, so now the present height is 10 centimeters after 20 minutes. Right now I'm just thinking whatever. So how fast means it is, how fast is changing. So change in height over change in time, right? So change in height in 20 minutes has been from 30 to 10 centimeters, because now the height is 10 centimeters, over time that has passed is 20 centimeters. So that is time is 20 minutes. So that is now equals to 20 over 20. So that is 1 centimeter per minute is the speed at which the height is reducing. Cool. When you solve this yourself and you feel that I have done something wrong somewhere, I would really appreciate if you leave a comment in the comment section, because I'm still not sure of this. I've done it. It might be correct, but I don't know why. I have a question mark in my head about it. So do leave a comment if you think it's right or if you think it's wrong. Cool. Have a good day.